One of the best and quickest way to learn secure programming is to see examples of insecure code and try to fix them in practice. And that's what we have made available in SecDim Play. SecDim Play is a novel game for learning secure programming and secure infrastructure. It has a collection of security puzzles or challenges. Each challenge is a program or infrastructure code with a security bug, a security vulnerability, or a weakness or insecure configuration. Our goal as a player is to find the security issue, fix it to get the score for the security challenge. Each challenge is a containerized app. The Git repository of the app or the source code of the app or the program is given to us. This Git repository is private, it is a fork, and which means we are able to read and write to it. We can explore the repository files on the server, edit the file and save it. We can also clone the repository locally, test it, and anytime we find the security and fix the security issue, we can push it. Anytime we save or push the code, it will save those changes to our remote repository, and the server will run a number of tests against our changes. If tests pass, we will be given the score of the challenge. Otherwise, we can try again if the challenge timer has not ended. Let's go through one example. Go to TypeScript game, click introduction.ts. We can see here the challenge has a duration of 1 hour. This means I have 1 hour to try to fix the security bug in this challenge, and I can try this challenge 10 times. Anytime this 1 hour finishes, I can try it for another 10 times. Hit play. Let's do this. As we can see, the challenge timer has already started. We have plenty of time to fix this. This is the content of that private fork repository that has been given to us. There is a directory called source. This is where we are going to spend our most time. This is where the main program will reside, and also tests. Tests are separated into two files: usability or functionality tests, security tests. Usability tests always pass anytime when we are given the source code of the challenge. However, security tests will not. These tests are like a specification for our program. We need to change our main program to follow these tests specification. Security tests are examples of what an adversary could provide or could input to exploit our program. They are quite interesting that without giving you an explanation or description of the security bug within the program, you will be given with the actual example of what an adversary could run against the program. Also, the security test, which we will see later, gives you some instructions on how this program should behave given that attacker's payload. So when our goal is to go back to the main program, and in this case of this TypeScript program inside this file, and try to make changes so to follow on with the tests. One thing always to remember, there is no point to change the tests, because these tests, anytime you push the code to the remote repository, will be overwritten before the server testing kickoff. Our goal is to change the main code to follow the specification. Now let's go ahead and review the main code. This program is a TypeScript. It uses a framework called tset, and it has a controller that will map to root and anytime we hit the request to root, it will respond with a status code 200 and with the string hello. Very simple. Now let's go and have a look at one of those tests. In this case, let's look at the usability test. We have usability test suite, and this test suite contains two tests, 1 and 2. We can read through the title of the test. When request root, it should return 200, and this is pretty much this line that we can see here. The second test, when we request root, it should contain hello. And this is the additional assertion or expectation that we can see on this line. Now to run one of these tests, we can change any file. I just go back to our main program or the main code, hit edit and add a comment. Now scroll down, hit commit and test. This is going to, firstly, it saved those changes to my Git repository, and as we can see now, it has started the server testing. Server testing will go through a number of steps. It will firstly clone the repository, so my latest changes will be copied. Then it will do some initialization to prepare that code for testing, and finally the test will kick off. Now first, it will always start with testing of the usability tests. As I can see here, my usability test all passed. Now following along with the security test. So I can see here test 2, test total passed, and then security test. And as I expect, the security test failed, which I'm gonna go look at it. We can also see the output of this test here, which will guide me into fixing also the program. Now it's a good time to go and have a look at the security tests. Security test suite, it only contains one test, and this test will expect anytime we hit root, we have SecDim return in the HTTP body. Now this challenge is just an introduction challenge. It does not contain a security issue. So let's just go to the main code and make that modification on line 12. And hit commit and test. I expect this time both usability and security tests to pass. One thing to make a note of here, to solve these security challenges, we can import from existing dependencies, which you can find it inside the package.json file. But we cannot install any new dependencies. The goal is we find our own solution using the given dependencies to pass these challenges. And as we can see, test has passed. I can see the outcome of the security test. It's all passed, and congratulations.